Well, I think it's time we officially dive headfirst into the electrical system. Let's go. Back in 2017, I began a full restoration of my 96 Bayliner by tearing it apart all the way down to the hull. From there, I began the rebuilding process, which included learning to fiberglass, rebuilding an engine and outdrive, learning to fair and paint, and even upholstery. Now, I've bought a 28-foot cabin cruiser, and I'm starting all over. Welcome, my name's Jared. Now get ready, because it's going to be a ship show. Alright guys, welcome back to the channel. My name is Jared. In this episode, we are going to take a deep dive into my plans for the electrical system on this boat. In the last couple episodes, we've been laying out the panel that all the stuff is going to mount to, but I haven't really talked too much about the specifics of the design and the approach I'm taking. This video is going to be completely dedicated to going over the system design and how this will integrate into the rest of the boat. So without further ado, let's get the camera moved over here, try and get sort of a top-down view as best as I can with the tripod, and let's talk through the system. All right, welcome to the top-down view. It's a bit of a mess right now. I'm in the process of kind of getting ready to wire everything here, but I want to start from square one and talk about the layout I have here, what all these components are doing, what they're for, how this will integrate into the boat, etc. So let's just kind of start from left to right here, because I think that'll make the most sense. On the far left here, what we have is a Victron. There's actually a Victron Lynx Power In. There's something that looks almost identical to this called a Lynx distributor. The main difference is it has some circuitry in it that gives you little lights here. It'll tell you if you have a blown fuse, things like that. The Lynx Power In is basically just a bus bar, but you can actually slightly modify it to add these bolts here, which will accept the mega fuses. So it basically becomes a Lynx distributor minus the intelligence inside. This is rated for 1000 amps. I don't plan on being anywhere near that, but what this does is gives you a good takeoff point. Again, it's a bus bar for high power, high current things. So that is this component here. This battery switch here, this is going to be the main disconnect from the house bank battery, which currently is going to be a Epoch, I'm not sure how to pronounce it, lithium. It's a 460 amp hour 12 volt battery. So again, this is the main battery disconnect for the house bank. So basically what's going to happen is I'm going to have a 4-aught wire coming out of this battery switch back into the engine compartment, which is where the house bank battery is going to be, just on the other side of the bulkhead that is right up against this edge of the panel in the aft cabin where this is going. And then on the negative side of the bus bar, we have a Victron Shunt. This one specifically can read up to 500 amps. You can get it in different ranges. Now, the closer you match that max number to your realistic maximum, the better resolution you get in the current measurement. If you put a 1000 amp smart shunt in a system that you're never drawing over 50 amps in, for example, you're going to lose some of the resolution of your measurement, and over time it may become a little bit less accurate when it reads the battery voltage and charge and all that kind of stuff. So you kind of want to match it to your system as best you can. So basically the point of this is this sits on the negative side of this bus bar, and this is the last component before anything goes to the negative post of your battery. So all of the current and power being drawn by all these components, the return path is going through this shunt. Okay, so as we move to the right, this component here is called a Cerbo GX. This is essentially the brain box of the system. All of these Victron components in this ecosystem can kind of tie back into this box and communicate with them. This is kind of the heart of why you want to stick with as much Victron stuff as you can if you're doing something like this, because it all ties into one convenient system that you can monitor from your phone, from a display, etc. As we're moving to the right even further, the big elephant in the room is the Multiplus II inverter charger. This is a 12 volt 3000 VA. VA is kind of like watts. It's just a more accurate measurement for power. So it's volt amps. Gets into power factor. It's a whole different video to talk about that. But anyway, this will also charge at 120 amps off of AC. So this will actually charge the lithium house battery very quickly at 120 amps. And if you don't know what an inverter is, that basically takes DC voltage into it and is able to output 120 volt AC. The reason this is so big is because it can handle that much current. There's basically a gigantic transformer that sits inside of here. It's kind of the heart of the system, and also why it's as heavy as it is. Now we move down to this component here. This is the Victron Orion XS 12-1250. You might be looking at this and seeing 12-12, and if you know anything about this stuff, that means it's 12 volts in, 12 volts out. And you might be thinking, why in the world would you have a DC to DC converter that inputs and outputs the same voltage? Well, you can use this for several different things. One is a power supply that can give you a more consistent regulated output voltage. Say your input voltage is fluctuating up and down based on battery state of charge, ripple from an alternator, all kinds of different things that would cause your input voltage to go up and down. This can output a more stable voltage at 12 volts. Or what I'm going to be using this for is a battery charger. The reason I have a separate battery charger when I just said I have a gigantic one here, the purpose of this is to take the starter battery, which is going to be connected to the engine and alternator, and that's going to get wired into this battery charger, and then the output of this can be configured for a bunch of different battery chemistries and allows you to charge lithium batteries from a typical lead acid battery / alternator setup. Now, you don't necessarily need this if you have a smart alternator or with an external regulator that you can configure all those charge profiles for lithium. I don't have that. I just have a basic kind of dumb internally regulated alternator on my Mercruiser engine. So the plan is to take a power wire from, again, the start battery, which will be charged by the alternator, run that into here, and then this will output the correct charge profile for the lithium house battery. That will go back into my Lynx Power In, and then basically feed that power back into the house battery when the engine is running. The downside of doing that versus an externally regulated alternator is I'm limited to the ampacity of this charger, which is 50 amps. So that is the purpose of this. The one other thing that is over here that we didn't talk about is this is the GX Tank 140. A lot of people won't have any need for this. The reason I do is if you remember back to the video where I was working on the plumbing and we put that pressure transducer in the water tank that's under the aft cabin floor. That pressure transducer works on a 4 to 20 milliamp scale, and that's how it integrates with the inputs and output, or the I/O, of the Cerbo GX. The Cerbo GX does not directly have the ability to read a 4 to 20 milliamp circuit, so in order to do that, you need this additional component that can provide the correct power to those types of sensors. That is, in a nutshell, the components that we have laid out here. Now, the things that are not here that you're not seeing, there will be DC wires coming in from the top right, kind of off the screen here once this is in the boat. That will be coming from the existing DC breaker panel leads. In addition to that, from the same place where the AC breaker panel is, I will be rerouting those AC wires so the shore power inlet will route down this way into the inverter, feed into the AC input, and then the AC output will then come from here and feed back to the breaker panel. This will automatically switch to generating AC and supplying AC current to those components that it's hooked up to when you're not on shore power. If you lose shore power, or when you disconnect and you go out boating and you still want to use those AC loads, this will automatically sense that that AC load is missing and will start inverting and outputting that 120 volts that you can use. That is why I need to integrate this into the existing AC wiring. Okay, now that we've covered all of the components, how they're going to lay out on here, let's talk about, oh, I did miss this one. This is a circuit breaker, and this is basically, I really just have this here more as a switch than anything, because it will be fused. The connection from here to here will be fused inside of the Lynx Power In. But if I ever need to disconnect this, now I know you can turn it off with the app, but if I ever need to do any maintenance in here, I'd rather just have this physically disconnected. That's basically the point of this. So it's a redundant circuit protection, if you will, but it just gives me the option to push the reset button. And then this circuit's open and I'm free to be able to work on this if I need to. Now that we have all the components out of the way, let me get a sip of some neural lubricant. So that brings us up to where I am now, which is crimping some very large battery cables. The configuration I'm planning on at this point is this first slot here is a 60 amp mega fuse in it. This will be run to the Orion XS. The next slot in the Lynx Power In will be for the inverter. Now I have this battery switch here. Basically this is going to live right about here. So we have these terminal's already crimped to go to the underside of the battery switch. This is going to get screwed in here, and I'm actually going to be running the negative kind of underneath, and that is part of the reason I put on these little 3D printed standoffs to raise up this battery switch a little bit more, and that gives me the ability to run this 4-aught cable underneath the switch a little bit easier. And one other connection that needs to go to the inverter from the Lynx Power In is one more ground wire, which is going to go to this center stud here with this terminal sitting on it. There'll be a wire going from here to this stud in here, which is the chassis ground. ABYC standards require that your chassis or equipment ground has to be no smaller than one size smaller than your main conductors. So in this case, I'm using 4-aught conductors. So this in theory could be 3-aught, but like most people do, they just run it in 4-aught because that means you'd have to buy 3-aught wire in addition to the 4-aught that you bought. So it's just more convenient to buy a little bit more of what you're already getting to run this equipment ground. Now, typically that is going to be, whoops, bumping the camera. That's going to be a green conductor for an equipment ground. However, I didn't want to buy one small little piece of green wire, so what I did is I bought this green expanded sleeving. So at this point, I'm going to go ahead and cut this chassis ground conductor to length, crimp the terminals on, get this flex sleeve on, and then we'll go ahead and install those conductors permanently, get them torqued down to spec, and then we'll see what that looks like. Okay, so there is our hex crimp. So I get some heat shrink on there, then we'll, well, before I do that, I'm going to cut the other end to length. I'll do the heat shrink at the same time. So one thing you definitely want to make sure of when you're crimping the second end is that you get the orientation of this terminal correct on a wire that's relatively short. If you're running a 15-foot run, doesn't really matter. You'll get enough twist in there. But on something like this, on this big of a cable, it's really hard to get this to twist. So you really need to pay attention. It's almost like plumbing with PVC. When you glue it together, you got to like kind of clock everything. So again, just make sure your terminals are aligned the way that you need them to be. All right, got those 2 lugs crimped on. Now, one thing I didn't talk about yet is you really should be checking the quality of your crimps before you kind of get on a roll. Like the initial one, you kind of want to check. And there's unfortunately really no good way to check a 4-aught crimp. I mean, you can pull on as hard as you want. That's a good like indicator. Like if you can pull it off, that's really bad. But technically a good quality 4-aught crimp should withstand almost like 1,000 pounds of pull force. So there's really no logistically good way to check that. But I do plan on, I have a little thermal imaging camera that plugs into my phone. Once I get all this stuff up and running, I'm planning to kind of run this thing up to the, kind of rev it up to the limit, and I'll take that thermal imaging camera and check all these terminals and crimps to make sure there's no hot spots. That'd be kind of one good way after the fact to check the quality of your work. But aside from that, like I said, there's really no good way at home to be able to check crimp quality. Take that for what it's worth. Okay, now again, because this is the equipment ground, like I said, I'm going to put this screen flex sleeving on it, and then we'll heat shrink the ends. All right, we got our heat shrink, or our expanded sleeving cut to length. So let me get some heat shrink cut, and then we'll melt all this on, and this will be ready to go in. All right, now that we got our main cables for the inverter made up here, got everything kind of just test fit real quick, and everything looks good. Let's go ahead and get these things mounted and torqued down. As far as this chassis ground or equipment ground, whatever you want to call it, on the inverter side, we have a stud with a nut that's holding it onto the chassis. The first thing we put down is this serrated washer. That goes on the stud. Then we go ahead and install our terminal over that stud. Next goes a flat washer, then a lock washer, and then the nut. And then on the other end over here on the Lynx distributor, again, we're going to the center post for this connection. And one thing, oh, I do want to point this out. There is some goofy shenanigans that you have to deal with on this Lynx distributor end sometimes when you're dealing with 4-aught wire. The terminals I'm using are called They're made by like Cellterm. You can get them on Amazon. It's, from what I've read, it's actually a really good brand of terminals. They're tin-plated copper, so good for marine environment. But they must be a little bit larger than others because I found that some things end up hitting inside of here. So on this one, if you can see it, there's actually like a little notch that I had to cut out because there's a screw on here holding this bus bar down. And that actually ended up interfering, so I had to take this to the bench grinder, grind away a little bit of a notch out of that terminal. Not ideal, but also not a big deal. As far as this one goes, I ended up having to elongate the hole in this terminal because it was hitting on some of these plastic parts of the housing. So on the Lynx distributor end, we got the terminal down on the chassis ground wire here, right on the bus bar. So on top of the terminal, we go flat washer, lock washer, and nut. So let's go ahead and get this one torqued down. I'm going to go ahead and torque down the ground wire as well. All right, now we're going to pop this separator back on. Oh, this is another weird thing I had to do. Again, because of the size of these lugs, if you can see this, the separator ended up having to cut away some of the plastic in here because the terminal was hitting it. Normally it's like half moon shaped like that, but it was hitting. So I had to remove some of that. But on these positive wires, I'm actually going to mount them to the underside of the switch first so I can use my torque wrench here, and then we'll flip it over, drop it down, and try and feed the wires through, and then we'll torque it into the distributor and the inverter. Now this is going to be the fun part. So these are short little wires relative to how big they are. So I think there's going to be a little bit of wrestling involved. Okay, so this is where things get a little weird. All right, guys, well, things are a little bit different than the last time you saw this 2 seconds ago because, well, 2 reasons. One is it's the next day. 2, I was reviewing the footage and for whatever reason, well, I know now my battery died on my microphone and I had no audio. So reshooting and catching up on what's happened. So I have torqued down all the battery cables here, got the positive in place. If you can see this, I've actually gone back. I forgot after I torqued these down, I undid them again because I forgot I wanted to label these. And I just have a regular label maker printed them out and put some clear heat shrink over it just to hold them in place. That probably seems excessive for something like this because it's kind of obvious this gigantic cable goes to the inverter. But my thought process is it takes an extra minute to do it. And I'll tell you what, Campion labels basically every wire on their boats. And that has been an absolute lifesaver with this rework and refit of this boat that I'm doing. So I know it seems overkill, but it takes a couple minutes to do it. So if 5 years down the road, I end up removing some of this stuff to swap something out or fix something or whatever, and I go to put this back in and who knows. Anyways, got the battery cables in place, got the bolts torqued down here. The next thing that I need to do is I'm going to start running the power wires, well, as much as I can for the Orion XS battery charger. So I got to run from the Lynx distributor down through my circuit breaker to the output of the battery charger and the ground. So we're going to get that done. Now, in this case, I'm using 4-gauge wire, which is a little overkill. I'm trying to minimize the voltage drop because it is a reasonably long run from here to the start battery. Now, this is compatible with up to 4-gauge. Now, with 4-gauge, you can't use a ferrule, so you have to stick on the bare wire. And I can tell you from just looking at this initially, is it is very tight getting this wire in there without any stray strands getting bent back out of place. So I'm going to focus here and try and get this ground wire in place, and then we will move forward from there. Okay, now I'm going to go ahead and torque this down. I have a torque screwdriver set to 35 inch-pounds. Okay, so with that ground wire in place, now I can start to route this the way that I plan, and then I can cut it to length. All right, well, we skipped ahead a little bit here. I didn't want to show you crimping wires again. It's kind of old. But as you can see, we have our 4-gauge wire installed, both the plus and minus, positive, negative, for the Orion XS. Got these torqued down on these studs. Got my 60 amp fuse in here, and you can see these routing over. The ground goes directly to the Orion XS, and then the positive is going to my breaker, which I can use as a switch again, and the other side goes to the out. So current is actually going to be flowing from the battery charger over here into the Lynx distributor, and then back into the house battery to charge it. Now, in addition to that, I also ran the power wire for the Cerbo GX coming through this cable track up here with the inline fuse terminated to these 2 extra studs on the end of the Lynx distributor. So that's taken care of, and I also ran the power wire for the Lynx shunt up underneath here, also to the positive stud on the Lynx distributor. So now we have the power run to run the Lynx shunt. We have the power run for the Cerbo GX. The Orion XS doesn't need power, it gets its own power. But I did run the VE direct cable coming up through here, again through this cable duct and into one of the VE direct ports on the Cerbo GX. And then I also have the VE direct cable coming from the Lynx shunt, which is running up around here, again through the cable duct and terminating to the Cerbo GX. That being said, the next thing that I need to do is alright guys, well I think it is time to actually wrap this dang video up, because we have basically installed everything on the system so far that we can do outside of the boat. My brain stopped working there for a minute and didn't realize that, but the more I thought about it, I realized, well, this is really all I can do here. Again, with that being said, that is going to wrap this video up, guys. I'm going to ask you guys to do me a favor. If you have any desire for me to go into any more depth on any of these specific components or anything like that in terms of the system design, all that kind of stuff, let me know down in the comments. If this was good enough, let me know. If you want to see anything specific on anything else here, let me know. Programming the inverter, all that kind of stuff. Let me know what you guys want to see. On top of that, just to bring you up to speed on the outdrive, that is still sitting in the garage. I haven't started painting that yet because it has been so cold outside. Now I know I have the heater in the garage, but I am afraid to start that process and God forbid lose power or something. I can't run the heater out there and it gets cold and ruins the paint. So I'm going to be waiting for a weather window. I'm not saying it has to get up to 60 degrees, it's still February, but I'm going to be pushing that off a little bit until I get a weather window that's going to allow for it. So that's why I've been tackling this stuff and trying to get this taken care of. In the next couple of videos, we are going to hopefully continue on the outdrive, weather permitting, but there's a couple other things that I can get done in the garage while I'm waiting for that, including rebuilding a marine toilet. Anyways, that is going to do it for this video, guys. As always, I hope you found this useful, and don't forget to like, subscribe, leave a comment. Again, let me know if you want to see anything more along the lines of this stuff. And yeah, thanks for watching, guys. See you in the next one.